Hello and welcome back to Physics for the 21st Century. What we have here is the labs for Newton's bench. This is the first lab that we're going to be doing. And that lab is on vectors, distance, and height. So we know about vectors being magnitude and direction. Magnitude is measured in meters or velocity in meters per second. Acceleration is also a vector. If you don't have a direction, it's a scalar. Speed is a scalar. Velocity is a vector. So direction can be measured in terms of, well, on a compass southwest, you can measure it in degrees, and we'll be using degrees, radians, etc. So when we look at the very simple trigonometry of what we're doing here, we have the opposite side of a triangle, the hypotenuse and the adjacent side, and the fourth variable being the angle. Now this angle as measured, we're going to use this angle arm protractor. So if I want to calculate the height of something, let's say it's here, I'm going to need to know a little bit of trig in the relationship between these four things. I want to use trig to calculate how tall this building is. Now, as you remember from the lectures, I know that tan of an angle is equal to the opposite side over the adjacent side. So then just doing some very simple algebra, I know that the adjacent side times tan of the angle will give me the opposite side. So I can measure the height of anything if I only know, and all I need to know is the angle and the adjacent side, how far away I am from something. Now, let's say I was going to do it for a bookcase or whatever, or a building, like in this case, or I can either measure it out using the tape measure you're given. I could use Google Earth. Between two locations, there's a roller tool that'll tell you the distance between those two locations. That'll give you that adjacent side in meters. We want to do these in SI units, meters. To figure out the angle, we have to use a protractor. There are several ways to do it, but we're going to use a protractor. And how we'll do this is you take this protractor and you put your eye where your eye focuses at the pivot, and then put whatever you're focusing on in between. So if it's a building, in between these 2 points. If I do that, for instance, I'm measuring the height of a bookcase over there. You don't need to see that, but just understand that. Then I can measure, and it depends on your protractor, but in this case, you see that the measurement, if the height of the building was measured in this particular displacement, then the angle is about 33 degrees here. So you align up your eye to that, get the amount of degrees with the adjacent angle, the adjacent length in meters. You can find the height of anything. I'm not specifying what you're going to be finding the height of. That's part of your experiment. It could be a bookshelf, it could be a building, it could be a telephone pole, it could be whatever. So in conclusion, make sure you list all the equipment when you do your OLAR for this particular experiment. For all the labs, make sure you fill out the methodology section completely. It needs to be detailed. Use pictures if you can. Assume the grader knows nothing about the experiment. Your writing skills are part of your lab grade. For a better grade, of course, as I said, insert pictures. Otherwise, it's difficult to assess your level of detail and the proper equipment use. So that's what you need to do for lab number 1.